Hey students, welcome back to part 2 of the review for our Unit 1 test. So on this part 2, I'm going to continue with number 5. This system of equations, if you look at it, it's XYZ, XYZ, XYZ on all of the equations. So we're going to go ahead and approach this with the Gaussian elimination method. So the Gaussian elimination method is asking you to convert it into matrix. So that will be 1, 1, 1, 2. 2, 2, 2, 4, -3, -3, -3, and -6. After you write the system as matrix, you need to focus on converting these as zeros. But I also told you during class to focus on first these two before you look at that. So we're gonna only be able to change one at a time. So now you have to decide which one you want to start with. I'm going to go ahead and start with the last one just because it just doesn't matter. So -3 can be canceled with a +3. And number 1 and number 2, the only one I can easily convert to a +3 is that one. So I'm just going to use row 1 to multiply row 1 times 3. And then what I'm going to have is 3, 3, 3, 6. And after I convert that row 1 to these numbers, I'm going to now add row 3. So again, I'm focusing on this one. So I'm going to add row 3, which is -3, -3, -3, -6. And then we're going to add downwards. So that ends up actually with zeros all the way through. When you get into situations where in your matrix you have that, so now we're going to have 0, 0, 0 all the way. We don't need to continue because this is telling you that is one of the special solutions. And it's either going to be no solution or it's going to be infinite solutions. And the way you can distinguish them is by asking yourself if you have a false mathematical statement or a true mathematical statement. So that means that something equals something, and false means that these are not equal. True means that something equals something, and these are equal, so that checks. So let's see what's going on right here. This is x, y, and z, and a number. So we turn this into an equation that is 0x plus 0y plus 0z equals 0. So we know mathematically anything times 0 is 0, 0, and 0. So we can just say that on this side of the equal sign, you have a 0 because there's nothing. And that's saying that it equals another 0. So is this a true or false statement? Well, that is a true statement, which leads us to conclude that our solution is not going to look as x, y, z. It's not going to look like that. Our solution is just going to say that it's infinite solutions. Okay, so that will be the answer to number 5, infinite solutions. Okay, so now I'm going to continue with number 6 and start the same way. So I analyze my system and XYZ, XYZ, XYZ are in all 3. So I'm going to go ahead and approach this with the Gaussian elimination method. So write all the numbers. And we are going to focus on converting these numbers into zeros, focusing first on converting these 2 into zeros. So you just gotta pick. I'm going to once again pick the last one, so row 3. And how can a 3 become a 0? So a 3 becomes a 0 by having a -3. And if I look at these 2 numbers, 1 and 2, the only one that can easily be converted to a 3 is that 1. So I'm going to use row 1 and multiply that times 3. So I can have a 3. But then I also have to convert all the others. So 3 times 1 is 3. 3 times negative 2 is negative 6. 3 times 3 is 9. And 3 times 11. 3 times 11 is 33. So that's row 1 multiplied times 3. And I'm going to add it to row 3. So I'm going to put 3, 3, 1, 8 underneath, add it downwards. I think this is actually a positive 3. Yeah, so my mistake. If you notice here, this is a positive 3. So that's actually positive 3. So we need a negative 3. To make that a negative 3, we need to multiply times a negative 3, which makes these opposite sign. So negative 3 times 1 is negative 3. Negative 3 times negative 2 is positive 6. Negative 3 times 3 is negative 9. And negative 3 times 11 is negative 33. And don't be afraid to make mistakes, students. Make sure you go back and catch your mistakes if something went wrong. So negative 3 plus 3 is 0. 6 plus 3 is 9. Negative 9 plus 1 is negative 8. And negative 33 plus 8 is going to be negative 25. So this is your new row 3 because we're focusing on this 0. So I'm going to go ahead and now draw the matrix that I have with the new row 3. 0, 9, negative 8, negative 25. And then copy down row 2 and row 1. So then now I'm going to focus on that 2 because again, even though I'm trying to make all these zeros, I'm still focusing on making these zeros first. So this 2 can become a 0 if I have negative 2. So I'm going to replicate the process, but now I'm going to multiply row 1 because we cannot use 0. 0 is not going to be able to multiply times anything to give you negative 2. So we're going to use 1, and we're going to do row 1 times negative 2. So negative 2 times 1 is negative 2. Negative 2 times negative 4 is negative 2 times negative 2 is positive 4. Negative 2 times 3 is negative 6. And negative 2 times 11 is negative 22. Then we're trying to change row 2. So we're going to add it to row 2. So 2, negative 1, 3, 13. We're going to add downwards. And that's going to result in 0, 3, negative 3, and negative 9. So this results in the new row 2 because we're trying to change this to right here. So that means our new matrix has these answers for row 2. And then row 3 stays the same. And then row 1 stays the same. So now we are going to look at how can we convert that 9 into a 0. That's where we're at now. We already got those zeros, and now we're looking at that one. So here when you use row 1, you are not wanting to use row 1 because 1 merged with 0 will change these numbers. So again, what you want to do is here pretend row 1 is not there and only focus on row 2 and row 3. So 9 can be canceled with a negative 9. Can 3 become negative 9? Yes. So row 2 can become a negative 9 right there if we multiply it times negative 3. Negative 3 times 3 is negative 9. And then you need to multiply the whole row. So we're going to have 0 in the front. Negative 3 times negative 3 is positive 9. And negative 3 times negative 9 is positive 27. Next, we're going to just put our row 3. So we're going to add row 3 to this. So 0, 9, negative 8, and negative 25. And this will result in the new row 3 because we're trying to change that 9. So when we add these, we get 0, 0, 1, and then 27 minus 25 is 2. So our new matrix we'll have the new row of row 3, 0, 0, 1, 2. The next one will be 0, 3, negative 3, negative 9. And then the last one, then the top, negative 1, negative 2, 3, 11. So because we have all 3 zeros, we are done with the Gaussian elimination method. But now in order to solve this, you need to use the substitution method. So you need to look at these as equations with the x, y, and z. And then these are numbers that they equal to. So out of these 3 equations, we can see that the bottom one has only one variable. So that will be like seeing it as 1z equals 2. The middle one is seeing it as no x. So we're going to put 3y minus 3z equals negative 9. And then the first one will be 1x minus 2y plus 3z equals 11. So these are the equations that are created from this. And again, the one that it's easy to solve for a variable, it's the small one, the z. So here, 1z equals 2. You can either divide by 1 if you want, process-wise, but it's going to end up with the same answer. 2 divided by 1 is 2. After we have z, we're going to now substitute that z value into an equation that will give us another variable. So between these two, the one that will give us another variable is this second one. So we're going to write 3y minus 3z equals negative 9. Substitute this z value that we found into this z right here. So 3y minus 3 times 2 equals negative 9. And then 3y minus 6 equals negative 9. Then we're going to cancel by adding 6 on both sides, and we end up with 3y equals negative 3. Divide by 3 on both sides, and y equals negative 1. So again, this is just a lot of steps, so repeat, slow down, pause, whatever you need to do as you're watching this video. So the last step is to solve for x. We're going to use the very top equation. We're going to have 1x minus 2y plus 3z equals 11. And we're going to substitute our z value with a 2. And we're going to substitute our y value with a negative 1. So still putting plus 3 equals 11, 1x minus. So here with the parentheses, we want to get rid of those by distributing. You're going to have 1x plus 1, because negative times negative is positive. And if there's no number, there's a 1. So negative 1 times negative 1 is positive 1. And then positive 3 times 2 is positive 6. As we solve for x, these are like terms. So you merge those together. 1x plus 7 equals 11. Then we subtract 7 from both sides. And we end up with 1x equals 4. And again, when it's 1 next to the variable, you don't need to divide, but if you want, go ahead, divide by 1, x equals 4. The answer will be 4, negative 1, and 2. And that will be the Gaussian elimination method for this problem. Okay, so to finalize the review, the last part was just identifying the types of solutions you have when given pictorial representations. You either have an answer of one solution, which is your x, y, z, or no solution, which is there's none, or infinite solutions. In order for there to be a solution, just like in Algebra 1, 2 lines had to intersect. In Algebra 2, we're looking at planes, so like pieces of paper. If you think about grabbing 3 pieces of paper and having them all intersect with each other, this image is the one that has 3 pieces of paper intersecting all in this very corner right here in the middle. So that creates that point of XYZ. So in this image, there's only one solution here. They're only all 3 planes meeting at the same time in that corner right there. On this image, we need all three planes to meet in order to create a solution. So even though you see all three planes here, you'll notice that in this corner, only two planes are meeting because the other one's way over here. In this corner, only these two planes are meeting because it's way over there. And then on this corner, only these two planes are meeting because the other one's over here. So this will be the no solution because they're never meeting together at the same time in the same location. On this one, this is actually seeing three papers just being crossed with each other. So they're definitely meeting in this line right here in the middle. This creates a line full of solutions. So all of these are points that they are all sharing, and then this is the infinite solutions image. On this last one, on the bottom too, this right here image, this image shows a little thickness there because that's actually two planes together in the same position. So just picture a paper and then another paper coexisting in the same place, so something like this. And then this one just crosses them. So definitely they're also meeting right here. These are all points. So that's also infinite solutions. Okay, and then the last one, number of solutions. We have, again, here an intersection of two planes, but the third one's over here. And then here we have two planes, but the third one's over here. So this would be the no solution. All right, thanks for watching these videos. I hope you're prepared for the test, and let me know how I can help.